There we go. All right. Okay, now I want you to like this. I want you to like factor label. I want you to say, it's a tool. I now have a new tool. You know, if a math teacher showed me a shortcut, or remember the first time a math teacher showed you a proportionality, this is to this, as this is to that. Did you ever do that? Or cross multiplying? Didn't you, when you learned how to use that tool, wasn't that good?
Yes.
I think so. So there's all kinds of tools that you can learn. They're called learning tools. All right, almost up and running. Here we go. All right, so what I did was I started with a problem, 18 donuts equals how many dozen? And I did it on purpose because everybody already knew the answer was going to be 1.5. Is that right? So I must not have been teaching for the answer. I wasn't really interested in, can you get the right answer? I was interested in teaching you a new way of doing a problem. And if you understand this, then you could have gone later and done the mole problem right here. And we did, didn't we? So let's go over the basics one more time. Here are the basics. What is factor label? What do you use it for? I need everybody's attention, okay? What do you use it for?
Convert.
All right, convert anything that can be converted into whatever somebody can. Okay, so the fancy name is dimensional analysis. Okay, if you have a parent who's a science person, a doctor, engineer, they probably heard that. Okay, because they like to use a fancy word when you go to college. Okay. Oh, what's always step one? Okay, now I've had people that when I give them a quiz or something and they don't know how to start the problem, I get, hey, what's always step one? Write down the given. Now, how do you write 18 donuts? You write 18 donuts over 1 because I need to know that the 18 is in the numerator and so is the donuts. I need to know where my numbers and labels are. Now, step 2. Step 2 is always the same. What label has, and forget the numbers for a minute, what label has to go away? Donuts, right? And so how do you get rid of donuts in the numerator? Put it in the denominator of this thing. What is this thing called? You guys got to stop because I can't teach while you're doing that, okay? What is this thing called? Step 2 is always multiply the given times a what? But where in the world do you get a conversion factor? You what? You make it from what? Equivalence. What are equivalents?
Two things that equal the same.
That's right. Okay, so look up here. For example, is 1 dozen donuts equal to 12 donuts? Yes. Well then, math says anything divided by itself, except for 0. Anything divided by itself, except for 0, equals what? Now that doesn't look like 1, does it? It has to be 1. This is the same as this. And except for 0, anything divided by itself has to be 1. And math says you can multiply anything you want times 1 and still say equals. Isn't that right? What's negative 5 times 1? Negative 5. And so I'm using 2 little math things, and I want to know how it works. I want you to know how this works, and that'll help you understand how to use it as a tool. Okay, now, if these are equivalents, how many different conversion factors can I make? Sean, I can't see your head. Can you? All right. How many conversion factors can I make, Sean? If this equals that, how many conversion factors can I make? Do you know what a conversion factor is? Okay, and that's why I'm reviewing, okay? I'm reviewing so you can... Okay. Oh, you're right. You haven't watched the video, I bet. Okay, unfair of me. How about that? Unfair of me. Matthew, you know.
One, or is it 1 first?
Can I make just 1? Can I make an infinite number? Whenever a teacher say infinite, that's always the answer, isn't it? Not this time. How many can I make? How many conversion factors can I make? If this equals that, how many different conversion factors can I make? How many people say 1? Oh, she agrees with you. Oh, he agrees. How many people say more than one? How many do you think, Ben?
I think it's two.
Two? How many say two? How many say more than two? Okay, now, can we back up a little bit? If you can't answer this question, I think you don't know how to use the tool. Let's back up, okay? This equals that, is that correct?
Yeah.
When you make a conversion factor, you put one of these on top and one on the bottom. Like this? Would that be a conversion factor? Would it?
Yes.
What about this one? Those are different. I can make two. If I say this equals that, you can make two different conversion factors, okay? With donuts on the top or the other one donuts on the bottom. So now, here's the key. Here's the key. How do you know which conversion factor to use? And this is the easiest part of it. It's the easiest part of it. You know?
Yeah. Use the same one that's in the given, in the numerator. So
What
if
has
it's,
to be in the denominator of my conversion
the
factor?
denominator has to be.
Just give me the label, not the number.
Donut.
It has to be, doesn't it? So I had to put donuts down here to cancel them out, and I put dozens here. And then where do I get these numbers? I don't get it from the problem. I get it from the equivalence, don't I?
Yeah.
And what number goes with dozen? Oh, let's take a look.
12.
Oh, no. What number goes with dozen? Then I put a 1 there. What goes with donuts? Well, then I put a 12 there. I'm not trying to tell you this is easy if you allow it to be easy. If you fight me at it, it's not going to be easy. Now watch how it happens. I actually, my other class just took a quiz on this, and they've already done a homework and another thing, but if this was a 10-point problem, if I made a 10-point problem like this right here would only be worth 2. You would get 8 points for doing this. Got that? Now, because I have to stress factor label, I actually will count off a point if you don't take a single line and cross those out. Now, why do I do that? Because what's the only label not canceled out? Dozen. And when that's the one you want, that's the first time you put equals. It's the first time you pick up a calculator. You don't need to touch that calculator until everything makes sense. Now let's go down here to this problem. You don't even know what a mole is, but you're going to get the question right. So here's the question. 100 grams of sulfur equals how many moles of sulfur? You say, wow, am I supposed to be able to do that problem? Here's what you should be able to do. Write down the given. Oh, I can do that. 2, multiplied by a conversion factor that has what? Yes, I'm sorry.
I was just going to ask you the restroom.
Where you going to go?
Restroom.
Where you want?
The restroom.
Oh, yes. Okay. All right, one more time. All of you should be able to write down the given. Is that correct? 18 or 100 grams of sulfur over what? Everybody can do that. Now, number 2, everybody should be able to say multiply by a conversion factor that has what in it? In the bottom. Everybody should have done that. And then it would be nice if I could put what in the numerator? See? Now, wow, all I need now is some numbers, some equivalents, don't I? And this is part of chapter 7, but I only need to teach you a little part of chapter 7. A little part. Here we go. 1 mole of sulfur equals this many atoms of sulfur. You don't even question that. When I say 1 dozen donuts, you don't question how many is going to be in the box, do you?
No.
You know it's 12. For a chemist, if I say a mole of anything, you know it's 6.02 times 10 to the 23rd. It's not, why is it? We don't get into that. Why is it 12? Why is a dozen 12? Do you know, Luke? I don't. We don't question it, do we? Why is a pear 2?
Because that's what we need.
I don't know.
Pair legs.
Because what? Pear legs? But why? Why call them a pear?
Because there's 2.
Why don't I call them an apple?
Because there's 2.
Okay, all right, ready? Now, so you have to have a little bit of knowledge of chapter 7. Here it is. You put 1 mole of sulfur equals this many atoms of sulfur And then this is the only hard part. You have to look on the periodic table and look for that decimal number for sulfur. Now, does everybody look up there? And it should say 32.06, and you put grams there. Now, for those of you who like memory tricks, if you go like the way I've always do it, it's mag, M-A-G, mole, atoms, grams. You like that?
Yeah.
Okay, mag. All right. Now, yesterday I asked you to take another element and do the same thing. So let me cover this up. 1 mole of carbon equals, all right, what do you think? Mag, atom, 1 mole, help me out. 6.02 times 10 to the 23rd what? Atoms of carbon equals, and I got to look on the periodic table, don't I?
Yeah.
And that's how many grams. Now, can you do that?
Yeah.
All right, I'll do one more. If you do this right, I'm going to move on. 1 mole of sodium. You finish it. On your paper. Just finish on your paper. Okay? You have to be able to come up with these. If I give you a mole problem like on a quiz, you just have to be, I'll give you a periodic table. You have to be able to put the 3 equivalents down. See how much money I have today. Oh, man. Oh, darn it. Thought I might have a $1 bill. I don't. Oh. Oh. Shoot. Shoot. Nobody here has change for a 10, do they? Anybody have change for a 10?
No.
Darn. All right. Let me see. No, I don't have $1. I was going to give $1, but I'll have to wait. All right. Does everybody have this?
Yeah, I did.
All right. Rachel's going to tell me. Rachel, go. Real loud. Loud voice. Oh, wait, I can't hear. Of sodium. Okay. And at 22.99, when I round to 3 sig figs, I'll get 23, so it's okay to put 23 there.
Yeah.
And that's grams, isn't it? So I'm not asking that much for you to remember that for the mole problems, right? Yes.
Do we get points off if we don't round?
Can you say what?
Do we get points off if we don't round?
Okay, what I do is when I round to 3 sig figs, I'm okay with carbon being 12, because if you round to 3 sig figs, it's 12.0, and sodium is 22.999. That's going to be 23. So I don't mind rounding to 3 sig figs. You get that? If you want to use 4, you can. But I'm okay rounding to 3. Well, anyway, what do you think about that? Now, if I had $1, what do I have that's worth money? Let me see here. Well,
He didn't.
all right. I have a pack of gum that I have no idea how old it is. But here's what I'll do. It's probably within a year. Okay, but it hasn't been opened. It has not been opened. But here's a pack of gum for anybody who can answer this question. If this equals this, how many different conversion factors could you make from those 3 equivalents? Now I want you, don't ask anybody else. I want you to think about it, and I'll go around the room and we'll get some answers. Just tell me how many different conversion factors can you make from this equals that. All right, everybody, just take a look. I'll give everybody time to think about it. Everybody think about it. Wait, don't give me the answer yet. You think you know?
I know.
Oh, man, I like that. Now, I think you'll be surprised when we go around the room and everybody doesn't give you the same answer as you.
Yeah. that's
All right,
wrong.
so ready? Give me an answer. How many?
6.
Nine? Aiden?
6.
6? Really? Is that peer pressure?
6.
9? 3? 3?
420.
How much? Say it again. Say it again.
6.
6? Okay.
Yeah.
Yeah, 6.
You didn't think it was 6
No, I
before.
didn't think it was 6, but I was gonna say
What? You might be right though. See?
Well, I don't know. 'Cause
Okay. What do you think, Sean?
it's,
I think 6.
Really?
Yeah.
And you can tell me which ones they are?
I mean, that's.
Okay. What do you think? Okay. 3? All right. Let's take a look. Ready?
Yeah.
I'll show you how quickly I can do this. All right. Let's just, instead of writing all these out, let's call this A, and let's call this B, and let's call this C. Okay. I'm gonna call A, B, and C. All right. Ready? What is an equivalent that I could do? I could put A on the
over B.
top and B on the bottom.
A over C.
I could put B on the top and A on the bottom.
A over
I could
C.
put B on the top and what?
C.
And I could put C on the top.
A.
That's it. That's it. Isn't that right? All right, who said 6? Okay. Usually I don't get hardly any people get this right. Okay.
I think 6 people said 6.
You said 6 also? Here, you give that. You can do it. You decide what to do with it.
I raised my hand.
All right.
I raised my hand first.
Well, that's true. That's true. You did raise it first.
I answered it.
Okay.
I said, no, it's your fault. You gotta tell them it's mine.
You can open it up. And
Hey, I hear it.
you can open it up. See if it's stale or not. All right. Anyway, real quickly, you can quickly see how powerful this is because if you give me 3 equivalents, I can make 6 different conversion factors. Everybody see that? Now, how do you know which one to use? I watch the labels. All right, let's go to our next lesson. Here's where we left off yesterday, right? So I've reviewed everything. And so if you weren't here yesterday, you can watch the video and you'll hear the same lesson a little slower, or you can just pay attention today. Now, there are actually 4 kinds of factor label problems I'd like you to be able to learn. The good news, you've already done type 1. Type 1 says you only need 1 conversion factor. So what I'm going to do here, did we do the weight thing yesterday here?
Yeah, we tried it.
Okay, so everybody in the world knows how much they weigh in kilograms except for you. So you can put your weight in there, and we're going to convert it to kilograms. Now, what you do is you write down a given. Let's pretend this is you. And you say, step 2, multiply by a conversion factor that has what in the denominator? What has to be in the denominator? Everybody. Pounds. It has to. And then it'd be nice if I could put kilograms in the top, couldn't I? Now, all you need is some kind of equivalent here, and I gave it to you. 1 pound is 2.2, 1 kilogram is 2.2 pounds. Get it? Yes? Does anybody know around the world what a typical baby would weigh in kilograms?
3.5.
Wait, ounces or pounds, kilograms?
Well, usually in here we call them pounds. Here, what do you think? An average baby around the world in kilograms.
3.5.
5? What do you think?
3.5.
Now, 5 kilograms would be 11 pounds. Sorry, that would be 11 pounds. That'd be a big baby. That's a big baby. When you ask somebody how big their baby was, if they say 10 pounds, usually people's eyes go like this. So somewhere around 6 to 7 pounds would be a typical baby, and that would be about 3 kilograms, wouldn't it? So around the world, most babies are around 3 kilograms when they're born. Anyway, can somebody give me this number here? I need you to use your calculator and tell me what that number is. What's 130 divided? Oh, by the way, I think I taught this yesterday. If it's in a numerator, you multiply by it. If it's in a denominator, you divide by it. Is that right? And multiplying by 1 or dividing by 1 doesn't do anything. So this is going to be 130 divided by 2.2. What'd you get?
59.0.
Okay, so if you weigh about 130 pounds, you're really close to 60 kilograms. You're about 59 kilograms. All right, you okay on that?
Yeah.
All right. Let's do type 2. All right, so what we're going to do here, yes,
Oh, if I didn't hear, can I go to the bathroom?
yeah. Hey, can you, let's make sure, let's try not to do this during class if we can do it. That's why we have breaks and passing periods, but go ahead and do it. But I don't really want to stop the class for people that did go to the bathroom.
I got that.
All right, all right. All right, ready? Now, this one is, you're going to think it's harder, but it's the same idea, all right? You know, the other day I was at Home Depot, right? I made that up, didn't I? Well, the other day I was at the hospital. And when I was at the hospital, I went to where all the babies were, okay? And I looked through the glass, wow, this one baby, I could tell that baby was not very old. I knocked on the glass and I said, how old? How old is that baby? And they said this, that baby is only 5 hours old. Well, I know you and I think alike, and you thought the same thing I did. Oh yeah? How many centuries old is that baby? And I know you want to know that. So what I want to know is, how many centuries old is that baby? You would have asked that same question. Okay, all right, let's try it. So what's step 1? And we don't have to write the word baby. All right, so here's my given. I'm going to put a little G there to remind me that's a given, all right? Now, what I'm going to do is, all right, I'm going to show you the beauty of factor label. I'm not picking up that calculator until I write equal sign. Okay, we're not going to do this the way, if I had given this problem to you yesterday, you would have said, well, let me think. Click, 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 click. And you probably would have missed it. You're not going to miss it. I'm going to show you how to do it, how to set this problem up. Step 2 is always the same. Here we go. What has to be down here? There's no way you shouldn't be able to do that much. Now, here's where you use a little strategy. I don't know the equivalent of hours and centuries. I don't know it. And that's what happens in science and technology sometimes. We don't have the exact equivalent we want. So we might have to use more than one. Do you know anything about hours and something that's bigger than an hour going towards century, though?
24
Hours and what, though?
days.
Okay, let's do that. And this is important. This has to equal that. 1 day is equal to what? 24 hours. Now watch my pen. I make you do that because, am I finished? Then do not put equals. Do not pick up the calculator. And what are we going to do? We're going to build another conversion factor. Now I'm looking at your faces. It's just okay. Every conversion factor equals 1. I could multiply it by 100 conversion factors, couldn't I? Now, automatically, what goes down here? Automatically. Now, I don't know days and centuries. Do I know days and something bigger than days? Years. Okay, and I'll show you that 365.25 days is a year. A year is 365.25 days. Now, the reason I tell you that is if you were going around the sun, that's what the Earth does, and that's called a year, by the way. When the Earth goes around the sun, if you start here and you go around the sun, you come back at 365 days, you're not quite there. So you have to go another quarter day. So it takes 365 and a quarter days to go around the sun. Well, they learned this a long, long time ago. They figured out a long time ago that it wasn't exactly 365 days. And so they said, that's going to mess up our calendars. Our calendars tell us we're supposed to plant the seeds during this month. But we haven't been paying attention to that 0.25 days, and all of a sudden we're planting that snow on the ground. What happened? How do we fix our calendars? And we still use it today. Every 4 years, a quarter of a day, quarter of a day, quarter of a day. Wait, every 4 years, that's a day, isn't it? So every 4 years on a leap year, instead of February 27th, February 28th, March 1st, every 4 years we go February 27th, 28th, February 29th. See that? And we actually have 366 days in that year. Okay, so that's why I put 365 in a quarter. Watch, equals 1 day. All right, we're getting close now. Now, look at this. Are we done? Look at the label. No, I'm going to centuries. I'm not done. All right, well, what has to be down here? Hey, there's no way you shouldn't be taking notes right now. Okay? You told me you want to get an A in here. Didn't you? All right. She did get an A. See? So look at what she's doing. She's taking notes. All right, ready? What do you know about years and centuries? You know that? What? I think that's called a decade. I think most people probably know this. What is it? 100 years is the same as 1 century. Now, wait. The only label not canceled out is what I want. Now I put equals, and now I pick up the calculator. But before you put the calculator, I want to show you something about the calculator. Either the calculator is broken or you are. All right, I'm going to show you an example of something about the calculator that you may or may not have been taught before. I bet that's frozen. Okay, all right, trust me on this, all right? Even though you've been using that calculator for a while, I want to show you something. I'm going to make it a problem here. Wait a minute. Let's do this. I gotta make it a problem. Start again. Okay, now, in just a minute, I'm going to have you put this in your calculator, okay? But we're going to do it in our head first. And we should get the same answer, shouldn't we? That's a $100 calculator. What's 50 times 4? That's 200. What's 200 divided by 20? Okay, now, all I'm asking you to do is clear your calculator and put this problem in there. And when you don't get 10, you look up and say, what? I know the answer is 10. Why is the calculator not telling me 10? Okay, do it. Put it in there, see what you get. Say 50 times 4, and then whatever you think you should do after that. I have a lot to teach you, I have a lot I'd like to teach you. Not all of you got 10, is that correct? Did anybody not get 10? Okay, let me show you what happened. When you're in middle school or elementary and they want to show you how to use a calculator, they want to make it simple because you're a middle schooler. And here's what they did. Multiply, write it down. Multiply, write it down. Then divide. If I was a middle school teacher, I would teach that also. See that? You're a big boy and girl now, but you don't understand that calculator. Watch right here. Ready? Tell me how you would put this in a calculator. Would you put 50 times? Okay. Hello. Okay. All right, thanks. Hi. Yes. Sorry. That's fine now. What was I saying? Oh yeah. Here. Ready? Tell me what you do in a calculator. Would you put 50 times 4, and then what would you do? Look at me. What would you do here? 50 times 4, what do you do with that? Divided by 4, is that right? Everybody pay attention. Yes, you would. Even if this is a problem, 50 times 4 divided by 4, that's what that means, isn't it? Now, everybody knows that. Now, watch what happens here. How would you put this in a calculator? 50 times 4 what? Divided by 5. So what did you end up doing with the 4? Divided by 4. What did you do with the 5? Divided by 5. But that's not what you did. Here's what you did. You did 50 times 4 divided by 4 times 5. Wrong. Wrong. Any number that's in a numerator, you're going to multiply by it. Any number. If it's in a denominator, what are you going to do? You're going to divide by it. Here, now do this now. Ready? Do this. Everybody clear your calculator. Ben, do you have a calculator?
Yeah, that's what I'm.
Okay, ready? Watch. Put 50 times 4 divided by 4 divided by 5. Enter. I'll bet you got 10 this time, didn't you? Let me show you something else. Watch. Clear. 50 divided by 5 times 4 divided by 4. What'd you get? I know you would. Let's play a game. 4 divided by 4 divided by 5 times 50. What'd you get? Now, you have to trust me. If you have a number that's in a numerator, you're going to multiply by it. Divide it if it's in a denominator. And we're not going to do anything with ones because multiplying by 1 and dividing by 1 doesn't change anything. All right, ready? Clear your calculator. We're going to find out how many century-olds this baby is. Ready? Look at my hand. 5. Put it in there. Put 5 in there. Oh, where's that 24 at? What are you going to do? Say divided by 24. Now what? Times 365.25. Divided by 100. Enter. Enter. All right. What do you have? Who's good with the calculator? Taylor, you have this one yet? What do you got? Yeah, and get it to me in scientific notation.
7.305 times 10.
Okay, so 7.205.
0.7305.
Ooh, that's not right. Do that again, okay? Can you do that again? Hayden, what'd you get? So, ready? 5 divided by 24 times 365.25 divided by 100. Enter.
546.
One more time.
7546.
7 what?
Is it 0.7546?
No.
Oh.
You know how I know this? Because when you get a big number or a really small number in a calculator, it will automatically put it in scientific notation. I know you got to say something point something, okay? There's no way your calculator said 0.7 something. All right, let's try it again. Everybody in here, I got to have somebody do this. Do you do it? What do you got?
0.7604. That's what I got. I got 0.761.
Oh, I made a mistake. I apologize. I apologize. Hang on.